Hello class, welcome to Algebra Concepts Lesson 1-1, which is all about numerical expressions. By the end of this lesson, you should be able to write and evaluate numerical expressions. So first, let's talk about what is a numerical expression. A numerical expression is a mathematical phrase that contains only numbers and mathematical operations. So a faster way of saying that is no variables, no letters, okay? So if I were to say like 3 plus 8, that's a numerical expression. If I were to say 3x plus 8, this is not a numerical expression because of this letter x, okay? So numerical expression cannot have a letter. Let's look at example 1, translating a verbal expression. So translate the statement below into a numerical expression. We have 1 plus 8 divided by 3. So the word 1 is going to become the number 1. And I'm just going to do straight up and down line like I normally do. Then we have plus, so that means I'm going to add 8 divided by 3. So my answer would be 1 plus 8 divided by 3, and it would look just like that using those symbols. Okay, that's all that this first part of this lesson is. All right, I want you to try this one. Translate the statement below into a numerical expression. 7 times 15 minus 2 times 9. Good luck. All right, hopefully for your answer, you got something that looks like this. You have the number 7, you have multiplication sign. Remember, I tend to like to use the little star for multiplication. I don't like to do this because it looks like an X, so I always add that extra line. And then I don't often use the dot for multiplication just because sometimes, depending on how fast you're writing, it can end up looking like a decimal. So I tend to use the star. Okay, so 7 and then times 15. And then I put a minus sign, and then I put 2, multiplication sign, and then 9. So hopefully that's what you got too. If not, ask for some help. I'm happy to answer questions for you. Example 2, translate a verbal expression with grouping symbols. So let's remember that grouping symbols are any forms of parentheses. It can be our curved parentheses. It could be our square brackets. It can be our squiggly brackets. All of those are considered grouping symbols. Typically, we don't use squiggly brackets as a grouping symbol in a numerical operation, though. Okay, so the two most common you'll see are the curved parentheses and the square brackets. The sum of. So a nice signal word for a grouping symbol is if you have the word of after a word like sum. So sum of implies that you're going to use grouping symbols. If you did difference of, so that subtraction of, that of, since it follows the word difference, would indicate you're going to use grouping symbols, okay? So another one could be product of, that would be your multiplication, or you could say quotient of, and that would be your division with grouping symbols. Okay, so the sum of. As soon as I see the sum of, I know I'm going to have addition. And then I'm going to have something, I'm going to have addition, and then I need to figure out what I'm adding together. So as soon as you see sum of, I want something I do, and this is something you can choose to do if you would like. You can do it differently. I usually underline the next thing that follows. So I would underline 5 and 9. So I know to stop after I do the word after the joining. So we have 5 and 9. So and is a joining word, so that tells me that 5 and 9 are grouped together, and they're going to go with the sum of. So it would be 5 and 9. So the sum of 5 and 9 like that, and then divided by 2. So I'm going to use grouping symbol. And then I'm going to say divided by 2. Another way to write this, I could also do the sum of 5 and 9, and you can write it as a fraction because that's another way to write division. Both of those answers are correct. It's personal preference, okay? So Whenever you have sum of, difference of, product of, quotient of, you're going to use grouping symbols. Okay, that tells you you're going to have parentheses, and then you look for the two pieces that are joined together with an and you put those in the parentheses, and then you continue on with your statement. All right, I want you to try this one. Translate the statement below into a numerical expression. The difference of 12 and 7 multiplied by 15. Good luck. All right, hopefully you ended up with one of these two answers. If you did not, please be sure to ask for some help or ask just clarifying. Maybe you have another way that works. This would be our difference of 12 and 7. So 12 and 7, that and puts the 12 and the 7 together. And then I put subtraction between them because the word difference. And then multiplied by 15. So in the top one, I wrote out the multiplication. In the bottom one, I skipped the sign and just wrote the 15 because, remember, if there's no operation sign, it means that multiplication is implied. All right, example 3. A person's handicap in bowling is usually found by subtracting the person's average from 200, multiplying by 2, and dividing by 3. Marley's bowling average is 170. Write a numerical expression for Marley's handicap in bowling. So a handicap in bowling is usually found by subtracting the person's average from 200. So I'm going to say 200 minus 170. That's what that first part tells me. And then I'm going to take that number and multiply it by 2. So I know I need to group these together, because that's the number that gets multiplied by 2, and then I divide by 3. So that's one possible way I can write this. I could also write it as a fraction. I could say 200 minus 170, put parentheses, and then I could just put the 2 outside of the parentheses because that means it's going to be multiplied, and then a 3 on the bottom. Both of those are acceptable ways to write this numerical expression. And I know some of you are going to be tempted to just solve it and write the answer. That's not what we're looking for on a lot of the problems today for your homework. So don't do that extra step today unless the directions specifically tell you to. But numerical expression means you stop right here. All right, question number 3. This one's for you. To convert a temperature in degrees Celsius to degrees Fahrenheit, multiply the temperature in degrees Celsius by 9, divide by 5, and add 32. Write a numerical expression to convert 37 degrees Celsius to Fahrenheit. Good luck. Hopefully you got letter A for your answer, and you said the fraction with 37 times 9 on top divided by 5, and then that added with 32. If you have questions about that, reach out for some help. I'm happy to help you. All right, let's look at a little more vocabulary. Sorry, I just said vocabulary, really weird. X to the n is read to the x to the nth power. The word power is used to refer to the value or exponent, or the exponent of the expression. So let's just remember that an exponent indicates the number of times a number is multiplied by itself. So if I have, let's say, 4 to the 3rd power, my exponent is the 3. It's saying that I'm going to have 3 4s all multiplied together. And then the base is the number that repeats. Okay, so the base is the number that repeats. The exponent tells you how many times it repeats. So evaluate each expression. So 2 to the 4th power is the same as saying 2 times 2 times 2 times 2, which can be really annoying to type into a calculator. So on your calculator, you're going to hit the number 2. On the left-hand side of the calculator, there's a little caret key that you hit, and then you would hit 4. And that's going to do that calculation for you. This is really handy when you get bigger numbers. But if you were to type 2 caret 4, you would get the number 16, and that would be your final answer. So then over here, 4 to the 5th power, I would hit 4. I would do the caret key again, and then I would hit 5, and that would tell me that my answer is 1024. Okay? If you have any questions about typing that into your calculator, let me know. I'm happy to help you. All right, I want you to evaluate this one on your own. 7 to the 3rd power. Good luck. Hopefully for this problem, you got 343. If you have questions about that, ask a friend, ask me. Let's get your questions answered. All right. The last kind of big topic for today is order of operations. So let's just review. The word evaluate means that you're actually going to get a number answer, a single number answer. And then order of operations, you guys have used this for a couple of years now. Sometimes we call it PEMDAS. Another way of looking at it are these 4 steps. You start with anything in the grouping symbols, so those parentheses. You do all of the powers, those exponents. And then you multiply or divide from left to right, and then you add and subtract from left to right. This is a good thing to take a screenshot of. If you are not going to write this down in your notes, I recommend taking a screenshot so you have it to reference while you do your homework. All right, so let's go through a couple of examples. I'm going to use the acronym PEMDAS again, just to help us solve, okay? So I don't see any parentheses, so I know I get to skip that. Exponents, I see that I have 8 to the 2nd power, which is 64, so I'm going to change that one thing in this first step. And then I don't see any more exponents, so I'm going to multiply and divide from left to right. So the first multiplication I have is that 7 times 11, which is 77. So everything else is going to stay the same. So I leave it like that. And then I'm done with all of the multiplication and division from left to right. So now I add and subtract from left to right. So I say 20 minus 17 is 13 plus 64 minus 77. And then I'd say 13 plus 64 is 77. And then I have minus 77. So my answer is 0. Okay, so I just went through those steps and changed one thing each time. This is the only chapter where I'm going to make you write out every step like this, and I know some of you are probably pausing the video to yell at me, but you have to do it. This is the only chapter I'll make you write it out in every step like this. In future chapters, you can start combining some steps. All right, I want you to solve this one on your own. Good luck. Okay, for this problem, hopefully you showed all of those steps and then you ended up at the number 23. If that's not where you ended up or your steps don't match and you're not sure why, please be sure to ask for some help. I'm happy to help you. All right, let's move on to our second to last example. Write and evaluate a numerical expression. Melly is playing a bowling game at an arcade. She rolls 2 balls into the 30-point hole, 4 balls into the 20-point hole, and 3 balls into the 50-point hole. Write and evaluate an expression to find Melly's total score. All right, so the first thing we find out, she rolled 2 balls into the 30-point hole. So we would say 2 times 30. And if we're trying to find a total score, we're going to keep adding things together, right? And then we have 4 balls into the 20-point hole. So I would say 4 times 20, and I would keep adding. 3 balls into the 50-point hole, I would say 3 times 50. So this is my first answer for this question. This is the writing the expression. Then it asks me to evaluate. So 2 times 30 is 60, plus 4 times 20 is 80, plus 3 times 50 is 150. 60 plus 80 is 140, plus 150, and then 140 plus 150 is 290 points. So that will be my final answer, okay? Then we're going to move on to the last example for today, where we're just practicing evaluating with grouping symbols, okay? So evaluate the expression. The first thing I'm going to do is parentheses. So if I do parentheses, 4 plus 5 is 9, squared all over 3, and then 7 minus 4 is 3. And then I have 9 to the 2nd power, which is 81, over 3 times 3 is 9. 81 divided by 9 is 9. Okay? So for this one, when you have fractions like that, I recommend simplify everything on the top, simplify everything on the bottom, and then divide them together. Now let's move on to the last one here. We have 15 minus, and then in our square brackets, we have 10 plus parentheses 3 minus 2 raised to the second power, square bracket, and then plus 6. So I'm going to start with the innermost parentheses. So that would be my regular parentheses right here. That 3 minus 2 becomes a 1. It's still squared. I have everything else is going to stay the same for now. All right, then exponents are next. So I still have those square brackets, and 1 squared is just 1. And then inside those square brackets, 10 plus 1 is 11. So now I've simplified everything in the brackets so they go away. Now I just have addition, subtraction, left to right. So 15 minus 11 is 4 plus 6, which is 10. This is the last thing you have to do for this video. I want you to evaluate this expression on your own. Good luck. Okay, hopefully for this problem, you ended up with 8 minus 5 on the top because you did the 2 to the third power first. And then 8 minus 5 is 3, so you had a 3 on the top of your fraction. And then 15 plus 9 on the bottom would become a 24. So 3 over 24 would simplify, it would reduce to 1 over 8. Remember, if you have a fraction that can simplify, we always simplify it. If you have any questions on this problem or anything else from this video, please reach out for some help. I am more than happy to help you. I hope you guys have a great day.